All right, so we had stopped here in the last lecture, right? So I think so. I completed the advantages of Dbms approach, and I explained this data dictionary. Then I explained categories of data models. Then again, I have to explain this component. Okay, this I said I don't know. You guys just learn from that. So components. Okay, that's all. Where did I go now then? Oh, I came to second model already. Different types of update operations. Yeah. So I'm in model 2, question 3, I guess, right? So question 3, did I already explain? Yeah, so okay, I already explained first. So I have to explain from here, explain unary relation operations with example. So see here, there are these five relation operations here. We can say these are the relational algebra operations also. If they might ask, explain the relational algebra operations. See, selection, you just remember the symbol S for sigma, right? So for selection, S for sigma, sigma symbol. P for pi, projection, P for pi. Rename R. Okay, I too forgot what comes for yeah, R for row. Okay, intersection is our basic max intersection. Okay, see here, selection is nothing but what will know. Selection, it will select a particular row, single row, and what it will do, it will display that row. It's like displaying operation. See here, operation. See, first we will tell what is unary. The operation that operates only on one relations are called unary operations. See, it only operates on one relation. Okay, just remember, operates on only one relation. Okay, are called unary operation. Then what is select operation? In relational algebra, see, like I said, in relational algebra, the select operation retrieves rows from table that satisfy a specific condition. It is often denoted by Greek letter sigma. See, only one line they have written. So main thing here is you can use these tables and occupy the space in your what to say question paper. I mean answer booklet. So see here, we have this table here, right? See here, employee ID, name, age, department. So if I set sigma, see here how the here sigma department equals to HR employees. See here, now I had here 1, 2, 3, 4 things I had, right? See rows. So what it's doing, wherever the department was HR, see, 1 Alice age 13 HR, then 3 Charlie 29 age and HR. So see select underscore. So select uh, what is that? The condition is equals to condition. That's what that is that you can say syntax for that. So what you will do, sigma underscore department from where you want to get, then department is equals to HR. Okay, so sometimes you can simply say departments, the rows of departments will come. So better is sigma condition bracket table name. Okay, so what is the condition where department is HR? You can instead write something else like IT also. You can create your own database. You can use your class, actual which class you're studying, right? That also you can use. Okay. So which class you're studying, you can actually use that also in this. You can create your own thing, everything. That is not what select. What it will do, it will select the particular condition which we have specified in the command and only displays those rows. Remember rows. Whereas projection, no, what it does, it displays the column. See, the projection operator retrieves specific columns from a table, removing the duplicate rows. Okay. So what it does not, suppose, okay, here see I have 1, 2, 3, 4. In fifth place again I have this first same thing. So what will do, instead of showing 1 to 5 things, it will only show this Alice thing only one time, because see same thing if it is repeated two times, it won't duplicate it, so it won't show the two values, it will just make it as one single time it will show. If it is same, it won't show more than one time. So the projection operation retrieves specific columns from a table, removing duplicate rows. You can simply here write here same thing, retrieve specific rows. Okay, if you write only rows here, that will become your what is that selection thing. If you write, then you can say it is denoted by Greek letter pi. Then example first, then syntax. So you have to write pi underscore condition comma table name, like that, something syntax. Once you just check in that notes or somewhere. If not, we already have, right? Let us see. If I try to search here, select, and okay, I have to click like this, up, select operation. See here, complete set of relation algebra. Uh, so here it will come up. One second. Okay, project operation, and this is select. See here, sigma. see it's here, see sigma, if I remove this, yeah, sigma select condition, then the comma r, that is relation. Okay, selection condition are same way for projection. See here, where did it go? See here, pi attribute list are their selection condition or simply conditioning, right? Here only you have to write attribute. Okay, whereas the third thing, see, and you can see here how he has written. So from the same employee table, what they are saying, see, pi name comma department employee. See, age is not displaying now, only name and department. Even EMPAD is not displaying, so only name and department is reflecting here. Understood? Renaming is nothing but see, you will just what to say, change the name of something. So now see here, I had here EMP ID. So what I'm doing, I'm making it as employee, complete employee ID, like that. So let us read the definition. The remaining so the renaming operation changes the name of the relation or the name of the attributes. Either it will change the name of the relation or the attributes. So here Alice also, you can change the value inside. Attribute is nothing but Alice, Bob, Charlie, and this is a value of age, department, values of department, values of employee ID. Either you can change the value, you can change the attribute, or you can change the relation name. Relation name is here, this headings. Okay. So then example, create your own example. Remember the stack. See, row, comma, here so much. So let us see here actual syntax, sequence of rename. Okay, see here. Where is the actual thing? Row. Hi. Okay, see here. So you can write row. This is nothing but s of okay. This is something else here. You can just write row condition, and then in the brackets like same way how here it is here pi attribute list r, right? Just write row condition r. That's it. That is enough. The relation about it can apply, select, leave orders in that. If you just write the example directly, but see, you can, if you write syntax and then the example, that will leave a good impression and you can write properly. I'm sorry, I cannot display properly. Just Google it, you will get the proper syntax, because Dbms, right? Even if you ask in AI and find the answers, it will give you proper answers itself. Why? Because it's very simple subject, complete about database. So even AI is built upon that itself, right? Whatever text I'm giving, that is my external view, and whatever it's collecting and showing me that what is that conceptual level thing, and the database from through internet, it's that conceptual level, that database and all is getting us. Okay, renaming you understood, right? Where we will change the name, rename or changes the names of a relation or its attribute. Okay, then intersection. Okay, intersection, very simple thing, or max intersection. So suppose here with, I'll say okay, let me take example of this DBMS instead of max. So see here, I have one table employee 1, and then I have another table employee 2. Okay, in employee 1 I have 4 names. In employee 2, suppose I have some new names. Okay, so now if I say intersection, okay, first employee 1 intersection employee 2. So what will happen? All these 8 names. So here 4, therefore, right? I'll create a new relation and then I'll insert all this thing. All these 2 places or the 2 tables, employee names will be added. Okay, see, the intersection operation retrieves rows that are present in both the relation. Okay, while technically binary, it's something used as unary operation. Okay, sorry, I said what to say, ulta. I said of union instead of intersection. My bad. Intersection means, suppose I have here table 1 Alice, Bob, Charlie, David. In another table I have Alice, Bob, and then suppose Ethan and Simon. Okay, so like that 4 things are there. So now if I do employee 1 intersection employee 2, so what will happen? Only Alice and Bob will be printed or shown on your screen. Why? Because these two are common in both the relations. You understood, right? Now, same as max. You can just take example of 2 tables here. Let me just zoom in. If I do like this, yeah, I'll zoom in more. Okay, no, see here in this they have shown it. Employee 1, employee 2. See, employee 1, 1, 2, employee ID 1, 3. See, make sure that everything is same to same, even the ID. Here, see 1, 2, Alice and Bob. Here, what? Alice and Charlie. So, what is happening here? Intersection of employee 1. See here, syntax nothing but employee 1 into the table name, intersection table name. So, result is the employee ID 1, name, etc. That's it. So then see, this is just normal notes of that assignment. So then once see what is integrity constraint, explain the importance of referential integrity constant. So first thing, let us read the definition. Integrity constants are the set of predefined rules that are used to maintain the quality of information. Integrity constant ensures that the data insertion, data updating, data deletion, and other processes have to be performed in such a way that the data integrity is not affected. Data integrity is nothing but, like I said, in the earlier thing also we had studied, like see, suppose I have uh, data types. First of all, data entry is data type. See, domain constant is nothing but the name of the domain should be unique and all like that and all. It will talk about that. Not null constant means we should not give null values. Entity integrity means it should repeat, should not repeat. More than see, entity cannot be null, or entity cannot be if you are creating an entity, it cannot be something which is already existing. If I have already some entity as employee, I cannot create again. Key constant is nothing but which is already present. For example, EMP ID if I take also, that is also is one key constraints and all. So those and primary key, for example, ID. You have already declared ID as one. I cannot declare one ID as one in other things. That is primary key constant. Key constant is same thing again and again. You name everything. If I try to insert same values for full complete that what is that attributes, it will we don't say duplication. I will say then referential is no, but foreign key refers to a primary key. Okay, so let me just tell you properly what is primary, foreign and primary key. So basically, it's like suppose there are two tables. One is order table and one is customer table. Okay, so now here there will be one key, here one key. So wait, let me think which shall I make. Customer order. Okay, so customers table is a primary key and order table is a foreign key. Okay, so suppose what will I'll do in primary key, I'll write order what to say, in this I'll tell customer whatever they have ordered, customer ID. Okay, customer ID have written as what to say primary key, and here what I'm saying foreign key as I'm using customer ID as a foreign key. Why? Because see, one order is prepared for whom it is prepared in for this customer ID. So instead of declaring customer ID inside this employee order table, I'm referring it through a foreign key, declaring this primary key as customer ID in this. So what I'm doing, foreign key, then I will say customer ID from then in the bracket employees, and then I'll write primary key like that. That one syntax we'll see later. So now what will happen? See, if there is, I cannot create a foreign key until and unless there exists this primary key. If there is no primary key, suppose the primary key is not there itself. Okay, if it is not there, then I cannot create this foreign key with the name of what we say customer ID. That's what is nothing but referential constant. And another thing comes is if I try to delete this, and already something is referring this key. For example, I want to delete this primary key, but already this foreign key is referring to this. So here also few anomalies comes, like if so three things will be there. That is nothing but retrieve, cascade, and what to say setting default values, which I had said explained. So either what I will do, if I am deleting this, I will delete this also. That is cascading. Okay, or else what I will do, I will cancel my deletion. So I will say I won't cancel. Okay, and then what I will do, another thing is I'll delete this and I set this as null. That is a referential integrity constant. Okay, here I hope you understood few things. In detail, if some question comes, I'll explain. Then what is this? What to say? Explain the importance of referential integrity constant. Okay, so I think here somewhere I had which is this inference rules. No, not this one. Integrity constraint. What is this? Explain informal design answer. Okay, explain importance of relational integrity constraint. What is this for? What is an integrity constraint? Explain. Oh yeah, integrity constraint, types of integrity, yeah, importance of integrity. See here four are there, but in simple ways I can. Array, what happened? In simple way I can explain you. First of all, like I said, see here. Maintains consistent relationship. See, referential integrity ensures that foreign key values in one table corresponds to valid primary key value in another table. That is referential integrity. So it makes sure this happens. Okay. So first thing you can talk about prevents orphan records, which is nothing but if there is what to say. See here also. records that reference non existing entities in related tables. So what are orphan records? It means a foreign key is there, it is referencing a primary key which does not exist itself. Okay, which means it was there but later it got deleted. So what it does, it manages this foreign, prevents orphan record, which means avoid situation where a record references another record that no longer exists. Means a foreign key, what to say, relating, referencing primary key which does not exist. This is one thing, right? For prevents this one. Then data accuracy means same thing. Foreign key are valid and corresponds to the particular primary key value in the referential table. That is accuracy. Orphan means it is not. It is referencing a primary key which does not exist. Data accuracy means it is referencing properly to a primary key. Okay, so which valid and corresponds to a primary key. That is accuracy. Then data management helps in maintaining logical relationships between tables, making data management easier and more reliable. Here, if you see, it simplifies the process of managing and maintaining data. For instance, referential integrity constants can automatically handle cascading updates or deletion operations. Like I said, referential integrity, so solution in that it was there, right? So in data management, you can say that maintaining and managing data. Okay, and then you can say automatically handling cascade, what to say, reject, and another thing, see here, deletion. Okay, so you can simply say cascading updates or deletions. This much is enough, ensuring that related records are updated and are removed appropriately. Then you can also talk about suppose data integrity. Like I said, data integrity means what? It ensures that changes made to the primary key in the reference table are correctly propagated to related tables. For example, like I said here, see, foreign key is representing this primary key, customer ID. If customer ID changes, this is not a good example. You can take as to say uh, volunteer mentor and their students. So many foreign keys will be representing one primary key, like so many students representing what is referencing one teacher mentor. If mentor changes, then it should update for this foreign key also. That's what data entity is here. So you can see here, and also prevent data anomalies. Okay, so data anomalies like see, by enforcing referential integrity, the database avoids anomalies such as duplications of record or mismatch. So it will avoid duplication and mismatching of records with the help of referential integrity. See, so many are there, but you can write any four or any five. You can either read from the right hand side in this column or in this. Then explain the following relational algebra option: join, difference, select, unit. See, select is the same which we said. Okay. Now join is nothing but it's like it will join two specific rows or columns. See, combines tuples. Tuples is nothing but combines tuples. Okay, wait, I forgot the definition, but it happens. Combines tuples from two relations based on a common attribute or a condition. Syntax is R joins condition S. So R, let me see, R and S will be there. This is one tuple. This is another tuple. Okay. Then you will write this like this. Some condition you will put here. Then you will say join things. Okay. Well, we'll see here. Condition specifies the criteria for joining the relations, typically involving matching attributes. Example: assume we have two relations: employee ID, name, department ID. Then I have department ID, and name department. So if I join these tables on the common attribute department ID, employee, this joins employee dot department ID is equals to department ID. Employee dot debt ID is equals to department dot debt ID department. This result in a relation combining employee details with the respective details. So what will happen? Here I had one, two, three values: employee name, department ID, employee ID name. Then here I have department name and department ID. So these two will combine and it will become say employee ID, name, department ID, department, like that. Okay, I hope you understood it. Then differences. Relation algebra is the same as set difference operation in the set theory. Wait, for this I think this is more good. So if I say JOI and join, okay, then perfect. It landed here. See, join operation denoted by that symbol here. It will come here. That this symbol. So it is used to combine related tuples from two relations into single join. Okay, why do we have to like get confused? Array, I was searching here. Tuple, did I, what to say? TUPLES. Okay, did I TU? It should come right. It comes in the beginning itself. Nonsense. See, now I can show you tuple. We should go for. Just sorry for this. Tuple. Why is it not showing in this first model, right? Okay. Main constructing, manipulating. So where were we? Yeah. Okay, I think there is no Wi-Fi connected. Sorry, just keep it off. Okay, till then we'll see here. This operation is very important for any relation database with more than one or single relation because it allows us to process the relation among relations, process the relationship among relations. So all the heading here, like I said, the headings in the table are all relationships. Okay, relations. Sorry, these are all relations here as the heading. So it will allow us to form a relationship between relations. Okay. See, a tuple is a finite or ordered list of elements. These elements can be of any data type, such as integers, characters, string, and all. See, then tuples are commonly used in mathematics. Oh my God, so much they have written. Define tuple. So I'll put in a bracket Dbms, and let's see what it says. Okay. So see, then wait. Let us go back to join. Join is nothing but it will join two relations. Okay, from the table. See here, the contents of database management system. A tuple refers to a single row or a record in a database. Okay, so this is nothing but this whole line is nothing but one tuple. Okay, you understood, right? It refers to a single row or record in a database table. It is an ordered set of values. See, it can either be column or row. Okay, it is an ordered set of values representing a specific entity or object. Okay, that clears it everything. See, join. Okay, join is here. Okay, first thing is join. So they are saying operations as relational algebra operation dot join. So in join, like I said, are this join simple, then condition here. So condition, you can say two tables you can take. Best is that employee ID, right? So employee ID dot dept ID is equals to department dot dept ID. Okay, same thing, both place the dot dept ID dot dept ID. Like I see here, employee dot dept ID, department dot dept ID. So that thing will combine now. Okay, those two things will combine. I hope there was one proper example for that. The so it's nothing. So general form of join operation on two relations are A1, A2. So, okay, so here one thing I can say, that say here the join, suppose that we want to retrieve the name of manager of each department as follows. The operation is very important. So combines the related tuples from two or relations. So here is basically what, for example, if I have to say, it's like plus thing in what to say. If I say, what is this, man? It's like max itself. Forget this plus. So what it does, whichever is common, right? Only that it will what to say pair up. Suppose see, there are this general form join operation is two relations R A1 to AN and S B1 to BM. So what is the is see R join condition S. So the result of the join is is a relation with n plus m attributes. So what will happen? Attributes will increase. Okay, but in that order, Q has one tuple for each combination of tuples, one from R and one from S, whenever combination satisfies the condition. So see, the conditions to satisfy from R also one should be there, and from S also, like S R relation from this table. Again, see, I confuse a lot. I'm confused. It combines tuples from two relations based on a common attributes or condition. So see, let some two relations are being joined. Conditions specify the criteria for joining the relation, typically involving matching attributes. So if it is same only, it will join. For example, see, I have so many values. Let me take here itself this table example. See here, now I have here these values. How here intersection is working, right? So same like intersection. See, whichever is matching, so it will join that and it will show you. Okay, like that you can understand that. Okay, explain the importance of this is done. Okay, I can ask this here and it will give me what to say proper answer also. Then so then till then we'll see difference. Okay, so for difference I had to come here. Here there is one table. Now see here, difference. Difference is not set difference. It produces the relation that includes all the tuples in R1 that are not in R2. See R1 in set we do right R1 minus R2. See here join. Where is join? R1 symbol join condition R2. So it will join R1 and R2. Let us see here union select join. See, there are inner join, outer join, and natural join. This is there in model 3. The join operation combines related tuples from two relations into single tuple. Okay, so if there are two tuples which will match the same attribute, so it will come into one. So example, if we have two tables, students and enrollments. So as inner join on student ID would combine student details with their enrollment records. Okay, so what will happen? If I see what this thing means is, so I have one two tables, student and enrollment. So this is student table and this is enrollment table. Both will have common what? Uh, and join on see enrollment student ID here also ID will be there. If I join using this student ID, no, so it will match all the so here which is student ID matched for this thing will be matched. For example, same way in this question where they said join, they said right join employee one dot debt ID is equals to department dot debt ID. So what will do, wherever debt ID department ID was same, right? So from the department table the name of the department will be joined to this thing. I'm taking a lot of time for this thing. So now, okay. So see, set difference on what R1 minus R2. So what will happen? Suppose I will give an example of my 1, 2, 3, 4, 5, right? And then another B is 5, 6, 7, 8. So now if I do subtraction, so what will happen? My result will be 1, 2, 3, 4. So what will happen? Whatever are the common tuples, no, that will be what to say eliminated. It won't be there. So it will remove the common tuples and only in this R1 what is remaining, that is also R1 minus R2. So only the common elements which are present in R1 and R2 are removed and the remaining tuples are shown in R1. Okay, you understood, right? That will be happening from that view thing. Then after that, then select like I said, same as the previous one. Select union is same as that max union. By mistake I said for intersection, right? So here I have one table, there I have two tables, so it will combine, it will add all everything. So here 1 2 3 4 is there, or here one employee one see here one employee table, here two employee table, both are having EMP ID name department, and here also same EMP name ID department. So what will do, it will add both the tuples both the tables. If there are some common rows, it will not write the duplicate ones. Okay, it will write it only one time like that. We can just read this and finish off, then discuss. This thing is a mess, so I'm not going to teach it still, and even I'm not teaching. Explain the relational average operation on the set theory with example. Union intersection minus operation. See, this I'm not going to explain because union is nothing but same max union, intersection is max intersection, minus is like I already said difference. Set difference nothing but minus one. Intersection I did already previously, union just now I did. Okay, so that completes module 2. So this is module 3. This is very simple one. Okay, so illustrates insert, delete, update, alter, drop commands in SQL. So insert, they are telling two things here. Okay, one is insert is used to add single tuple to a relation. We must specify the relation name and list of values for, I don't think I did this. For list of values for the tuple, the values should be listed in the same order in which the corresponding attributes were specified in create table. So we simply write at create table, just write full. Okay. Uh, Suppose employee in this we had. Then first is what I'll say ID. employee ID, EID, then I have name, then department, then salary. Okay, four things are there. So if I'm inserting, right, I cannot insert values in ulta ways. First I'll write name, then I'll write age. That is not, so we should not do like that. That's what it's saying. According to this value itself, the way we have specified the data type, according to that itself. So the value should be listed in the same order in which the corresponding attributes were specified. The way attributes were specified, in the same way the data value should be inserted. Okay, see here. First, you see for this example, say example, so create table like that. Something you can type and write the normal table. Very simple. Create table employee open bracket. Then what to say? Employee ID EMP ID int comma. Then name varchar. Then comma. Then department varchar. Then salary decimal. Decimal it's a decimal 10 comma something 2 like that. Then finish it off. That's it. That will get over. Then okay, then a second form of insert statement allows to the users to specify, sorry, to specify explicit attributes names that corresponds to the values provided in the insert command. The values must include all attributes with not null value, null specifications, and no default values. Attributes with null are allowed or default values are the ones that can be left out. A variation of insert command inserts multiple tuples into a relation. So one is insert one and insert many like that. That's what they are saying here. Okay. See example. Okay. So what they are saying means, see here another thing what is it? So they create a table works on info in which all the thing where ID data structure type they have declared the variables and or if I say attributes. U3A is they set up. Then U3B what they're saying, they're doing the insert thing. So insert into works in on info. Employee name, project name, hours per week. Same according to this. Employee name, project name, hours per week. From see from you don't have to write this project P and all. From works on the W, comma employee. See from works on P comma works on W comma employee, where P is equal P dot P number is equals to W dot P number and W dot yes. This thing if you skip also it's fine. You understood what's insert, right? So delete. So insert into table name. See syntax is insert into as it is table name values. Okay, then whatever value you are writing value name, okay, like that. I can also do like first insert into employee, then in the bracket of employee you can define the structure how it is attribute how it is specified, then you can say values like this. Both are the same. If you write two examples, that's good. Delete command syntax, delete from table name, where you can say employee ID is equals to something, where department name is equals to something, okay, where name is equals to something like that. So the delete command removes existing records from a table based on specified condition. It can either delete table itself. Okay. For that another command is there, but delete command is not used to delete a table. It only delete tuples from the existing records from the what to say existing table. Syntax, okay, understood. Give write on big nice aram sexy. Delete from students where student is equals to 1 like that. Then update command, it will update, okay, it will modify or change the things. See, the update command is used to modify attribute value of one or more selected tuples. An additional set clause in the update command specifies the attributes to be modified and their new values. For example, to change the location and controlling department number of, see, it's not necessary you have to do so much. You can simply say update employee set salary is equals to, okay, set age is equals to age plus 1, where what to say, see okay, this is itself good, right? Set salary is equals to salary into 1.1, where department number is equals to 5. So somewhere or else you can say employee ID is equals to 1 because he or she done a great job. So you want to increase, you can either say salary plus something or salary into 1.1 like that also. See, that is nothing but update. Simple thing. Then alter is nothing but three things are there. In it contains adding, deleting, or updating. Okay. See, the alter command modifies the structure of an existing. See, it modifies the structure, not modifies the values. Okay, modifies the structure of an existing table that can include adding, deleting, or modifying columns. Okay, so first thing, adding the column. Alter table. This is the command syntax. Alter table. Table name add column name and data type. So say for example, employee table was there, only employee ID, name and salary, and I wanted to add a column name department. So I'll say alter table employee add department, then int. So what will happen? A department column will be added, which is a type of int. So 1, 2, 3, 4 will be there. If it is varchar, then department varchar you have to draw. Then drop an existing column. This is what deleting an existing column. So alter table, same thing, drop column. So here only column, directly write column. You don't have to write the data type here. Drop column. Then here alter table, table in the same way, modify column. So one by one you can write three things. For each thing there you have to write the definition. You can explain this aramse. Alter table student, add age int. See alter table we are adding this thing. Same you can give for everything of a syntax example, then drop command. See, like I said, we will be having to delete the complete table or database, right? See, the drop command removes an entire table or entire database or other database object. Syntax to drop a table, drop table, table name. Drop, if you have to drop a table, you write drop table, table name. So then side in the example, drop table employee, then drop table, write two examples. Then you go for what to say, drop database, database name, university, drop database, then something else, company, like that you can write. Okay. Informal guidelines of relation schema. Okay, four are there, which I had removed and kept here properly, the good and nice ones. Now this one, I think it will come now here. Yeah, this four things. See, four are there. Okay, so same thing here. They have given the complete whole notes, and the whole thing it is generalized in this four things. Don't worry that it's AI generated or something. I have crossed it. It is perfectly same to same and correct. See, a clear semantics of attributes means ensure that the attribute in a relation have a clear and meaningful interpretation. Each attribute should represent a single concept or a property. Okay, so simple thing you can also see. If you read this example, you'll understand. In an employee table, attributes like employee ID, name, and hire date should clearly represent the employee's ID itself, name itself, and hire date itself. So in employee ID, I cannot write. See, though employee ID is int, right? If I have to int int, I can write my phone number also over this. So you should not write phone number in place of employee ID. That's what it means. Clear semantics of attributes. So ensure that the attributes in a relationship have clear and meaningful interpretation. Interpretation means what to say, giving them or assigning values to them. Each attribute should represent a single concept, or you can say the values assigned to an attribute should match the specified attribute. Okay, whatever the value is being inserted should match the specified attribute, which means it should be related to that attribute itself. Like that, you can simply write your own. Then reducing redundant information, which means avoiding storing the same piece of information in multiple places. Instead of saving the same thing in multiple places, what it will do, it will prevent multiple avoiding, it will avoid that some same piece of information in multiple places to prevent update anomalies. In the sense, what will happen? See, four places I have now, 1, 2, 3, 4, I have saved them. If I save in do the changes in here, it won't affect here. So that's what it is saying. So one place, if they do, it should be like that itself. Okay, in multiple places to prevent update anomalies. Insertion, deletion, and what are the update anomalies? That is insert, delete, and modification. Okay, this same thing we had talked, right? What are the what is that, violations and all? We can talk about that itself. Okay. Then next, what is functional dependency? Explain the inference rules for functional dependency with proof. So functional dependency is a constraint between two set of attributes from database. Okay, which means functional dependency. So if I have to say, okay, wait. First, let us understand with an example. Then see. A functional dependency FD is a constraint between two sets of attributes. Two sets of attributes. Okay, there is one attribute A, one attribute like that. Okay, in a relational database, it specifies that if two tuples have the same values for same attributes in set X, they must have the same values for attributes in set Y. Okay, in that sense, here see, here something was same, like for example, which I can say. Mm, did they give an example? Okay, he has given an example. In a table of student, if student ID uniquely determines student's name, then student ID implies student name is a functional dependency. Okay, so see, each student will have their, so each employee will have its unique employee ID, right? So that is nothing but functional dependency. So each ID is what determines another attribute value. So it's nothing but that in Max third module same we had that the functional right function from A to B like that itself it is, which means B is a subset of A in this according in Dbms it's like that. Okay. So, given a relation R, a set of attributes X in R is said to be functionally determine another attribute Y also in R. Okay, return X. R is nothing but one relation. For example, you can say student ID, student name, and all. Okay, in a same employee student table. If and only if each X value is associated with at most one value, so it should be related at least with one itself. Any one, for example, Y means at most one. They are saying department are there, right? Department can be common for most of the people. So at least for if this not, it's not common for anything, then it won't be functionally dependent. Like we have a small many people are in CS department, right? So that's what it means. So at most one means it will be hey wait at most one it means so only one values. Okay, sorry. For example, USN itself at most one means maximum one, less than equal to 1. So less than equal to 1 means what, 0 or 1. It can be either be empty or 1. It can be there or not there. Sorry, I have a small mistake. It happens. See here, this is the easiest thing to remember, the inference rule. That is, what is that? Reflexive, augmented, and transitive rule. Transitive rule is something, right? The same in Max. Reflexive is what? It is, see, according to this rule, if B is a subset of A, then A logically determines B. See, if B is a subset of A, then A determines B. Okay. Then augmented rule. It is also known as partial dependence. According to this rule, if A logically determines B, then adding any extra, which means see now here we have this thing already. A determines B. If I multiply A and B with the same thing, or if I add or cross product, if I do for A and B like AX, and then it will become here Bx, then still A will determine B. That's what it means. Transitive rule is same like that max transitive rule. If I have A comma B, then I have B comma C, then there should be A comma C, right? That's what. If A implies B, determines B, and B determines C, then A also determines C. Understood? That's what nothing it says the transitive rule. It can be said if see same thing or A determines B and B determines C, then it can be said that A directly determines B. Then union rule. Union is nothing but see first what we have to say B, okay, B is a subset of A and C is a subset of A. Then A determines B and A determines C, which means union rule states that if A determines B and C, so A determines BC. So it can be written as A determines B and A determines C. Okay, BC is nothing but B determines C, like sorry, B determines C. And if this will come here means A determines B, which determines C. If A is determines B, not B is a subset of A. If C is a subset of B and B is a subset of A, then obviously elements of C will be present in A, right? Since elements of C should be present in B because it is a subset of B. If B itself, if and B is completely a set of A, then obviously the elements in C will be in B, elements in B will be in A. Then decomposition is ulta of what to say union rule. So if you have A determines B and if you have A determines C, then A determines BC. Like that you can write off. Then pseudo transitive. So according to this rule, if A determines B and BC determines D, then what to say BC determines D, which means A determines B and BC determines D. Then AC also determines D. Okay, pseudo here it is property. If X determines Y and YW determines Z, then XW determines Z. In the sense, if I have, okay, yeah, I already have. See here, A determines B and BC determines D. So they are saying now AC will determine D. How? Because BC is nothing but B determines C, which determines D, and A determines B, right? Here it is D. So A determines B also, A determines C also, and A determines D also. So already B, C determines D is there. So I can simply write AC determines D also. Okay, simple like that. It is much is not there. Then here this 2A question. Consider two sets of functional dependency. So they are saying F is a functional dependency and E is one functional dependency. Here A determines C means C is subset of A, AC determines A, D is subset of AC, E determines AD, and E determines H. So what they are saying, both are equivalent. So this is equivalent to this. You are saying F is equivalent to E. Then E is equals to A determines ED and E determines AH. So now how I will do? See, from F to E, if I'm taking, check if E is a subset of F. So I have to check whether E is a subset of F. How I'll do? First, I'll determine AC. I have AC here. So this is comes under AA, and then I have EE. So this two comes under E. So first is what I say. I'll deriving A to C and A to CD. Deriving A, it determines CD in E from F in E. Okay. Okay. First we are determining E. Okay. Then we'll go for F. So what is saying? First A determines CD in E. Where is that? In E from F. So how to derive that? A determines CD. We have A determines C in F. Okay. So I have A determines C in F. Then I have AC determine D. Okay. This two is there. So now what I will do? So first same thing. You will simply what to say? Consider two terms, that is T1 and T2. See, from A determines C and AC determines D, we can combine these as follows. So what you have to do? First, if A determines C, then for any T1 and T2, T1 into A is equals to T2 into A, then C1 into T1 into C is equals to T2 into C. Okay. For A, C, you will write same thing. Then if using A determines C, we can derive that AC derives D can be used when A is known. Therefore, we can deduce the A determines CD because knowing A gives us both A and D. Okay, so if I know A, right, A is a universal set here. If best thing if you have to understand here, first we'll start with A. A determines C, and A determines C determines D using AC determines D. Okay, so see, AC determines C, like I said, AC determines D. Okay, so A determines C. Then A to, sorry, we had AD, right? Okay, AC determines D. So this can be written that A determines D. How you can say that A determines D is that, see here, AC D. Where is that? Let me see it properly. A determines C, then AC determines D, right? So here I have to say that A determines AD. Wait, so confusing. A determines CD. So see, I have A determines C, then AC determines D. We can use this pseudo transitive thing, right? So I can now simply save that AC. See, AC, A determines C, then AC determines D. You can simply say from pseudo transitive rule you can type, and you can simply pair A and C determines D. See here AC determines D is nothing but A determines C determines D, which means A determines D also, A determines C also. So AC will obviously determine D, which means if I cross do A and C, it will give me A itself, and D is a subset of AC. That's what. Same thing. See, one thing you will observe here, notice here, whatever is there, right? They are simply giving this T1 into same thing is equals to T2 into same thing. See, T1 into A is equals to T2 into A. T1 into C is equals to T2 into C. Then deriving E is equals to AH in E from F. Now see here, I have here E determines AH. Here you see here I have E determines AD and I have E determines what to say H. Okay, which means E determines AD. Okay, means let me just erase this whole thing here. I need some neatness. Okay, so this can be written as E determines A determines D, and E also determines H. Okay, so here what they're saying, A is a subset of E, D is also a subset of E, and H is also a subset of E. So E implies ADH. So E implies now ADH. E implies here H will come. What I am doing is nothing but in this place I am substituting E as this whole thing. Therefore, I can say that E determines AH. I can say E determines AD, AH, DH, everything. So E determines here. Simple we write, so easily we wrote off. Therefore, F plus F to the power of plus includes A determines CD, and it means F inverse, it is nothing but pre-image of E. Okay, so therefore F is E is a subset of F. We proved. Now I have to prove that F is also a subset of E. So here what I am doing. So first I have to prove that A determines C and AC determines D. In this I have here A determines CD, which means A determines C and A determines D from union rule. Therefore I proved this already. Then again I'll write A determines C determines D from A determines CD. Therefore A determines sorry, AC determines D. I can also write A determines CD, AC determines D. Suppose it was F determines G determines H. I can say F determines GH or FG determines H. It will cannot like that. So we proved this also, like that. Simply have to prove. Then E is equal to E determines AD and E determines AH. Here E determines AH. So which means E determines A and E determines H. And we also have that A determines D. So I can write that first thing what I can do. Okay, let me clear this again. Okay. So this thing I can write as E determines A. Same thing again and again I'm doing. Determines D. Okay. So here I can see that E determines A and E determines D. Then I'm also I have to take here, right? So here D won't come. Sorry, I have to prove this with respect to this E subset. So I have E determines AH, which means E determines A determines H. So from this I can say that E determines A, okay, and E determines H. Now here I have E determines AH. Here what I can do, I can simply add here. See what I can add here. It determines D. This determines H. E determines A determines D determines H. From what? From A determines D. We know that A determines D. Okay. Here already we have proved. Or else we can take here also. From this we can say that A determines D. So E determines A D H. So you will write E determines A D H. Therefore E determines A D. Like that simply you can write and just prove off. See here also they have done a lot of things. See one by one, same thing. Each value they are taking and doing. This has been asked for how many 10 marks I guess. So let us see here how many marks it has been asked for. Module 1, 2, 3. Yeah, see 10 marks they have asked for. First you will tell about this one. So I think you can write this. You just see here if I'm scrolling slowly. So conclusion like this. E can be see from one thing. See one this much. For one by see since I have four, so here four things should be there. One, two, step two. Okay. Here one was yeah, three is here itself, and see here four. I said correct, right? See why? Because it has 1, 2, 3, 4. Here it will get over in 2 steps, and here it will take 4 steps. So this is more than enough for that. And what is the next question? Explain the types of update anomalies in SQL with example. So we have insert anomaly, delete anomaly, and update anomaly. So what is update anomaly in SQL refers to issues that arise when performing insert, update or delete operation on a database due to poor schema design. Okay, so these anomalies can lead to data inconsistency and redundancy. The main type of update anomalies are insert anomaly, update anomaly and delete anomaly. Okay, like that you can just write for that. So we'll start with what is the insert anomaly. You have to talk about anomaly and then how you can solve it also. An insert anomaly occurs when we cannot add certain data to the database without other data, which means if you are adding some data, another extra data should also be written with that. In the sense, see now how insert will work. Insert into employee values. So see, employee has employee ID, name, department ID, and department. So I'm in insert when I type values. In values, if I'm giving only two values instead of four, so only employee name and department name I'm typing. So it will be anomaly. So without this, I cannot insert. Though, see, now for example, we have a college, right? In our college, suppose only computer science and what to say, AI branch is there. There is no civil branch, but I want to create a what to say table or row for civil branch, like. Uh, Student name and sorry, okay, student ID I can create for department that branch, right? So it can repeat. So I'll have one college code 22 what to say, if mechanical, I don't know mechanical, so I think it will be ME or something like that. Then 001 I can keep for that. So first ID, so I can keep department name, department ID I can keep, but I cannot give student name and student ID for that civil or mechanical branch. Though I want to create, even though no students are there, I want to create a branch. Suppose a college is having a civil branch, but no students are there, but it should exist in the database, right? But I cannot write because of these two things. So here, that's what is the issue here. So if so same this example, if I want to add a new department finance with department ID 30, but no employees are currently assigned to it, we face a problem. We cannot insert this department without providing employee ID and employee name, which we don't have. So here what you can do? So what you can do? First, you will create, divide this table. Divide means after creating, you don't do like that. So what you do? Directly what you do? Employee table is different. You make employee table different, and you make department table different. So now what you can do? So if you want to insert finance department and with department ID, so only two relations are there in this table. So it will get added. See, you cannot give null values also. Okay, that is not allowed. Null value is not allowed. It is a violation. So what you can do, separate the information into different tables. So employee and departments. So department. So what you do, just delete the table. Okay. Okay, just delete the table and give here. So department ID, department name, 10, 20. So here see, I added my finance. So I don't require here employee name or employee ID. Same way, everywhere we are just separating it. Same thing, same example. You have to repeat for everything. So don't worry about example. In update anomaly occurs when changing data in one place requires multiple updates in several rows. In several, see more than one row I have to do update. In the sense, now see here, I have here what to say, employee ID and department. Suppose there are only two departments, which is sorry, AI and computer science department, and I have 60 students. Half are suppose think AI and half are suppose computer science. Now, if I want to change 15 students from AI branch to CI department, okay. Now, what I have to do? I have to know if suppose that is there in this table one by all the tables I have to keep updating. That is a headache, right? That is one anomaly. So wastage of time and so much storage also. So now what I will do? I'll separate the tables itself such that instead of writing 30 times AI department and 30 times CI department, I just have to write two times here. Only two times I have to do. So now I can update department name where okay department name where department is equals to HR. Okay, department name as what to say HR. What is the human health human resource where department dep name is equals to like that. Okay, for that this also you will have see but separate the okay you will have that update command right. From that you can see that command update table name where department as equals to employees, like that you can write. Then delete anomaly, same thing. if you want to delete something, suppose a teacher was there, some record was there, and you want to, like, a teacher is leaving the college or the student is leaving the college. So no longer, okay, for best example is what to say, if I am in best is the teacher leaving the college, or the student leaving a school. So college, if I leave my college, so should my so here if there is a table, it contains everything about me. So student name, student phone number, contact details, address, admission details, everything. Now this student left the college. So if I have to delete the student, it is deleting all the, what to say, information also. So that's why what I'll do. Again, I'll separate the particular things and do it. That's it.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.